Hello, my name is Paul Rushton, and I'm with the Northeast Florida Woodturners Association. A couple of months ago, I did a demo showing how to make a small segmented bowl like this one, which you're going to see in the upcoming demonstration.
Okay, hello everybody. This is Paul Rushton speaking to you from the Jacksonville Beach Woodcraft store. We're doing a demonstration today of simplified segmented turning, and I'm going to show you how to make this small bowl right here that's got a bottom ring and 4 segmented rings attached to it. So we're going to duplicate this bowl today. Very simple. The first thing you have to do when you're going to build a segmented piece is come up with a design and a plan. So for design purposes, what you need to do is draw your vessel. First of all, is draw some sort of vessel. You can draw it on a computer and computer-aided drawing tools. If you don't have that or you're not that resourceful, you can do it on graph paper. Whatever works for you. I like to use the computer-aided tools because it simplifies the process and I can do it a little faster. When you draw your design, make the walls of your vessel or your bowl a little thicker than your intended final result. That thickness will give you a little margin when you do your measuring and ensure that you don't undershoot the size of the pieces that you need to make your vessel. Now this vessel here is this one here. And so I'm going to show you the plans for this entire segmented vessel, but what we're going to do is only make the bottom 4 rings. So these are the same plan. The bowl is the bottom 4 rings plus the base of the vessel. If you choose to later on, you'll have the entire plans for the whole vessel if you choose to do that. When I make a vessel, I do it in 2 parts. You do the bottom piece and you do a separate top piece. And at some point along the way, you will join them together before you do the outside turning. Once you have your basic plan drawn, then you would start by putting lines across your vessel or your bowl at whatever height of wood ring you want for each of the rings. In this case, all of these rings are 5/8 of an inch tall. So 5/8 of an inch, 5/8, 5/8, 5/8. And this is as far as we're going to go today, is up to number 4. So after you get some horizontal lines drawn here, then you want to go and measure the size of these boxes. You want to size these boxes on here so that when you build the stack of rings like this, what you're going to do is be building this stack of rings like this that I'm showing here. And I'm going to turn this actual stack of rings in a little while. But you're going to build that stack of rings, and you want the ring that you make, such as this one, to fully encompass your vessel. So if the vessel is going to go through here or through here, the whole vessel wall has to fit inside this ring. So that's what this represents right here. You're looking at ring 3 from this vessel, and ring 3 is this tall and this wide. So when you build ring 3, it needs to you'll know how big ring 3 needs to be by measuring this distance and this distance. The overall diameter of the ring, the inside diameter of the ring, and the width of the ring are all given from the drawing. So here's an example of what that looks like. This is ring 4 shown here in bold. excuse me, so ring 4 is just shy of 5 inches in outside diameter and is about 3/4 of an inch wide. Then you also need to decide how many segments are going to be in each ring. In the case of this vessel, I chose to make it 8 segments around the circumference of the vessel. So you need to compute, and there's tools to help you do this, which I'll talk about in a few minutes, but the very simplest method is get the outside diameter of your circle, multiply by 3.14, which is pi. So pi times the outside diameter of a circle will tell you what the circumference of this circle is, which is how many inches it is to go all the way around the circle back to the starting point. Once you've got that number, you divide. I would add a little bit of fudge room because you can see that the circle is a little. You want the rings to be larger than you want the glued up ring to be larger than the circle. So add a little fudge room in there. Take 5 times 3.14 is 15.7 inches all the way around. And you say, well, I need 8 segments, so you divide by 8. Each segment needs to be about 2 inches long. Here's a segment for ring 5. It's 2 inches long or a little more, and it's 3/4 of an inch wide. So that's what you're shooting for. You get all that from this drawing here. 5 inches in outside diameter, 3/4 inch wide. Here's the formula for anyone who needs it. And here's the formula again for this particular segmented ring. You'll need to cut 8 segments of about 2 inches long and 3/4 inch wide. The angle that you want to set the saw at needs to be, for 8 segments, it has to be 22.5 degrees. So you would take 360 divided by 8 is 45. So this angle is 45, and then this angle is 45 in here, and each side of this piece is 22.5. So that's how you get that. So I know that was a little bit complicated perhaps. I will tell you that there's really good tools out there that you can use. You just plug these values into the tool and it will tell you all the answers. There's a spreadsheet located on our website, the Northeast Florida Woodturning Association website at jacksturners.org, and there's a tool out there called the segment sizing calculator that I put out there a couple of years ago that you can just plug all this information into and it will spit out the results. If you have any questions about how to do this, I don't want somebody to get hung up on arithmetic and geometry and spreadsheets, so don't shy away from trying this because it's too complicated or you don't understand the arithmetic and the math. Please call me. I will help walk you through it, and I will help you design your vessel if you need me to. The spreadsheet spits out something that looks like this, which gives you all of the numbers that you need to cut all the segments. How many segments? It will also compute for you is when you cut segments, you're going to cut them out of a stick of wood that you're going to make, and you'll cut, and then you'll flip the stick over, and you'll cut, and you'll flip the stick over, and you'll cut. So you don't have to cut both sides every time. You can cut one side, and then when you cut the next segment, it'll cut the second side, etc., etc., etc. The segment calculator on the website will tell you how long of a stick you need, right here, segment board length, how long of a stick you need to cut this many segments at these specifications, and then you won't have any guesswork at all. This allows for 5 inches of extra space to protect your hands from the saw blades. Very important. So when I talk about a stick, for the vessel that I'm demonstrating today, these are the sticks that I made to cut all the segments for this. So what I'll do is this is for ring 1, this is for ring 5, one of these is 2 and the other is 3. I apparently cut the numbers off of them. But I'll cut all these sticks, and then I'll cut them all to the right length. I oversized the sticks for this demonstration purposes so that I would have these leftover stubs. But number each stick and then cut all the segments. The beauty of segmented wood turning is that when you come across flaws in the wood like this or this, not sure you can see that one, this or this, you can just cut those off and there's still plenty of wood here to get all of the wood that you need to make segmented rings. When I build a stick, I always put a line on one side so that when I'm cutting it, and when I cut it, we'll turn it over, cut it, turn it over, cut it, cut it, cut it. So I always put a line on one side so that when I get done cutting all of the pieces, if there's any misalignment in the saw blade, in other words, anything that's off of perfectly horizontal, I can line the pieces up with the line that I drew, and it will automatically, just because of the geometry, eliminate those errors, because one error will cancel out the other when you put these two segments together. If there was a tilt in the saw blade, it would be the same way on both of these segments. So this is a pro tip, I guess. Just put a line on here so that when you glue these segments together, you can stack them with the lines all straight up or on top, so that all the alignment errors will cancel each other out. So let's see what's next. So those are sticks. Next we got to cut segments. And you need some sort of method for cutting segments, such as a miter saw or a table saw with that you can adjust to cut the correct angles. So you can use a miter saw. You just need to set it at the right angle and then chop pieces off, put a stop block on the miter saw so that you can get every segment the same length. If I use a table saw, and this is the jig I use most often, this is the front of the jig. Let me turn it. This is the front of the jig. The front of the jig is this way. I know you can only see part of it here. And I will align the jig. I'll raise the saw blade. I will put this little stop block in here. At the correct distance from the saw blade for the segment edge length, I clamp this stop block in place, and sometimes I use this clamp if I'm cutting really small segments, and I run it through the table saw. I will hold this down with this little hold down tool so that I don't get my hands anywhere near the saw blade. So I always keep my hands away from the saw blade. And I use this hold down tool I made. This is an Allen wrench and a piece of wood that I turned, and I sharpened the Allen wrench into a point. I use this tool a great deal. So that's the way it works. So I will put my board in here, cut my segment off, and then you flip the board over, cut the next segment, flip the board over, cut the next segment, etc., until you get all of the necessary segments. There's another tool which the segmented wood turning world has invented, called a wedgie sled. Where'd my wedge go? There it is. And this works basically the same way. This is the front of it, and on this side you would it sits in a table saw slot on my table saw, and on this side you would put some sort of fence or stop block to get the length right. You would put your stock. You would set this using this plastic wedge here, and these are store-bought wedges. They're rather expensive. If somebody has a CNC machine, they could make them. When I did the Taurus, I needed over 2,000 segments, all exactly the same size and dimensions. So I went to the trouble to build this wedgie sled, and I bought this just for the Taurus that I made. This one is exactly 18 segments per ring, so this is a 20-degree wedge. When you put it in here, you loosen these, you fit that in there, and now you've got two fences that are exactly 20 degrees between them, exactly, because you just set them. And if this fence is a little high or low, if this fence, if it's not exactly, if it's a little off one way or the other, since the difference between these two fences is exactly 20 degrees, even if they're a little off of center, if it's 20 degrees, the segments will still fit because you drew the line down the stick. So if you do that, you'll get exactly 20-degree segments every time. These little plastic inserts are pricey, but it was worth it to me since I was making 2,000 segments to get them all exactly right the first time. So this is called a wedgie sled. Somebody in the segmented world invented it. He's well known now. They sell these sleds commercially, or you can build your own like I did. Okay. You would you can see you'd slide it through you'd set it with the stop back here on your table saw, and you'd slide it through, cut the segment off, pull the segment away, and you'd flip it, and then you'd move it up here and cut the next segment. And then move it back here and cut the next segment. It's really a terrific invention by the fellow that invented it. So those are two ways, plus the miter saw is another option for cutting segments. Get as close as you can to the exact angle, but don't fuss over it too much. If it's a little bit off, I'm going to show you how to correct that in a minute here. So don't fuss over it too much. Oversize your segments a little bit. Don't fuss about the angles too much. Precision is not necessary here, believe me. There's plenty of ways to get margin so that you can make a beautifully designed and constructed vessel. As you're cutting the segments, write the segment ring number on every one of them. I have cut thousands of segments, and you'll put them in a plastic cup like this one, for example, and then it'll spill and you'll have a mess. So I always write the ring number on the segment every single time I cut a new segment. Good, we got 8 of them. So here is a set of 8 segments for ring 5 of this bowl. So this will be the top ring of this bowl. And I'm going to show you how I glue these together. They'll fit into a ring. Notice all the dark lines are facing up. And what I like to do so that I can eliminate any misalignment of these angular cuts is I will glue it in 2 half rings. What I do is I'll glue it with dowels, just 3/8 inch dowels, and into half rings, and I'll show you that in a second. So for clamping, I use these hose clamps. I buy them at Grainger. I looked up the price. It's about $20 for a set of 10 of them. I don't buy the expensive stainless steel ones. I just buy the regular mild steel clamps. I'm not going to use them in outdoor applications, etc. And they're not very expensive. I do go to the trouble to buy these quick release clamps instead of the ones that have a fixed screw so that I don't end up screwing and screwing and screwing. So I can do the quick release, and the metal band slides inside the quick release mechanism. Grainger.com. So at home, when I do this, I generally put a piece of wax paper on my bench, and I use this glue bot. If you haven't got one of these little gizmos, this is a terrific invention. Instead of waiting for glue to reach the tip of your glue bottle all the time, this has got it readily available right at your fingertips. Put a little glue on. I spread it around with a little flux brush. Put a little more on there. I put plenty of glue on so that I don't have to glue both sides. Well, I usually glue both sides. I take it back. I'm not putting glue on this end because I'm going to glue that end later. So right now I'm going to build 2 half rings. I hope my clamp is big enough. I just brought the small ones. They sell these glue bots here at Woodcraft. I only discovered them a couple of years ago, but it is a terrific invention. You can see how quickly I can get glue onto these surfaces without waiting for the glue to upside down the bottle and waiting for the glue to reach the cap. So we stick this in here like so. Put our dowels in. I try to get the dowels about centered in the piece. That helps ensure that the pressure is equally applied all around the might be a little close here on the clamp. Oh yeah, we're gonna make it. I thought it would work. Okay. Might not work. Yep, okay, we got it. All right, so I'm happy with that. I take this opportunity to make sure that all of them are flat. So that's flat, flat, that's flat, flat. Just whack it with a mallet to get it flat. It doesn't matter so much if it's not, but I'd rather cut the excess off rather than sand it off. So you're going to have to get these surfaces flat later on. And the closer you get them to flat right now, the easier it will be for you later on. So I wipe off the excess glue and let that dry. I usually let these dry overnight. And tomorrow come back and take it apart, and what you'll find is you'll have two perfectly glued half rings. Now, when you finish your half rings, you might find that they don't fit together perfectly. Now, these do because I sanded them already. So what I do is I take them to my disc sander, and I just have a disc sander that's mounted on my lathe. I got this piece of melamine, that's it, it's melamine. I got this piece of melamine. I attach the faceplate to it so that it fits on my lathe. I spin it. I built myself a table that comes up on that mounts on my lathe, that comes up like this, and I can slide the table back and forth like so. I get the two pieces of the half ring, and I just hold it on there until it's perfectly flat. I'll put a pencil line on here and a pencil line on both of these ends. I hold it on here until the pencil line's gone. My table helps hold it flat, and then I do it with the other ring, and then they're ready to glue together. So that takes out any misalignment that you might have had in your angles that you are cutting the segments at. So try to get them close, because you don't want to sand away very much of this wood after all the trouble you went to make this segment and the ring. But that is a way to get rid of any small misalignments that might still exist. Then I glue the ring, the other clamp please, Ed. And I glue these two half rings together. In similar fashion. And we'll make sure that the joints are flat. That's good. That's good. Set that aside to dry. Come back tomorrow and you've got your ring ready to go. So here's an example of a completed ring that we'll have for ring 4 and ring 5 in a day or two. I think we can go over to the lathe now, and I'll show you the next steps. Well, it's me again, and we've moved the whole operation over to the lathe now, so I'm going to show you how I build the vessel and build the rings and attach the rings and center the rings and prepare the rings for the next ring. So first I like these glue blocks, and I'll show you what I did. I bought a mess of these big nuts at Granger.com. They cost about $5 a piece, but it's the same size thread pattern as my lathe. It's 1 1/4 inch 8, I think it is. And I hollowed out some pieces of, I bought a bunch of them. I hollowed out some pieces of maple and I embedded it in there and filled it with epoxy. I also put a hole in the side so that I can use a pry bar to tighten it or loosen it, because sometimes they get stuck on the lathe. And then I usually attach a waste block of some sort. This happens to be a piece of sycamore board that I glued onto this piece of maple because I want to kind of preserve the maple so that I can use the same glue block over and over and over. And I've used these dozens and dozens of times. So I like these glue blocks. Now this piece of sycamore I stuck on here is not smooth and flat, so I'm going to start by getting that ready to accept the bottom piece to be glued on. Here's the bottom piece. I just cut this out of a piece of walnut. You can see that's the circle that shows the outer perimeter of the piece in the final vessel, in the final bowl, and I'm gonna smooth this off and then glue that on there. So here we go. Check for flatness. I always use this kind of a ruler right here, and I look in here to see if I can see any light through the crack. I don't see any right now, but this isn't as smooth as I want it to be, so I'm going to just take another skim cut off of it. Glad this is just a waste piece. So we're pretty good here now. You can see I gouged it with that gouge. That's why they call it a gouge, I guess. So I just want to glue this on here. And for this demonstration, I'm going to use this glue here, this quick Titebond Quick and Thick. And I use this, I wouldn't use this at home, but I'll use it here because it sets in about 15 seconds. So it's very quick setting. Now this, you have to wait for the glue to get up to the cap. So I can glue this on and have this thing set up in a matter of seconds. But I want to wipe my finger off on the sponge when I get done. So. And I will use the tailstock to put a little pressure on it. I got a small hole in the, I put a little center punch in there so that I know where the center of this thing is. Glue that on there, and all I need is 15 seconds for that to be set, and it will not come apart. That's a glue that I discovered when I was doing a lot of open segment turning, and I'll show you an open segment vessel in a little while. But when you're gluing open segments on, you have to glue one segment at a time on, and gravity will make it fall off. So and you have a quick setting glue, you only have to hold it for 15 seconds or so, and then you can do the next one. So it's a time-consuming, laborious process. But this glue is really good for that process. So I'm going to use that glue for the rest of the demonstration today. So that's how we glue on the bottom ring onto a waste block. I'm going to set this piece aside. We're done with that, and Here's another, this one's mounted on a faceplate, but here's the same idea. Here's a partially constructed vessel. This is the base, this is ring 1. I forgot to mention something. When each ring needs to be flattened on one side. So again, I use that same disc sander, and after the ring is built and before it can be glued on, you have to flatten one side. I did this one at home already so that I wouldn't be making a sawdust mess here in the store. But you put the disc sander on here, and I just hold it against there. Watch your fingers. For really thin rings, you gotta attach it to something. But for a thick ring like this, it's perfectly safe. Just hold the ring against the sander, put pencil marks around it, and make sure you just get it flat. This ring is now ready for glue up to this piece, except this piece is not ready to accept the glue yet. So we cut these rings, this wood is about 3/4 of an inch thick. And as I said, we're shooting for a 5/8 inch thick ring design. So I've got to take some wood off of here, and I got to get this flat just like I did the ring 1, or piece number 1 of the piece I just showed you. So we got to turn this a little bit to get it 5/8 of an inch thick and flat. So let's see where we're at. Still a little too thick and pretty flat, but needs some improvement. So we'll turn it a little more, take another cut off it. Okay, we're right at 5/8, and the inside needs to get some material removed. Okay, very close. So at home, I will usually go to the trouble to sand this surface flat and smooth and make sure it's perfectly flat and smooth. So I built this little sanding paddle thing. I use spray mount adhesive on a piece of 150 sandpaper and attach it to this board. And I use spray mount adhesive and a piece of 220 on this side of the board. So I got a sanding board. Got another one at home. It's got 120 on it. We will, I don't quite like the way that looks yet, so I'm going to take a little more material off the center. And I will typically get it where really close and as flat as I can get it, and then use this. I'm not going to make a sawdust mess in here today, so I use this, just hold it on there like so, and get it perfectly flat and smooth. Glue the next ring on. How do you suppose we're going to get this thing centered in? Where are we going to go with this ring? So what I like to do is I use some kind of conical shaped object in here, like that, for example, attached to my tailstock to center it and to apply some pressure. For bigger rings, you can use, you don't have to buy an aluminum thing, I just happen to have it, but for bigger rings, you can build your own. So this is one I use for larger rings, and I've got another one at home that's probably 10 or 12 inches in diameter. So make your own conical shaped thing to center and apply pressure to the rings. You must make sure that for this ring, that this doesn't go all the way through and touch the bottom. So you can get in trouble if you don't plan ahead. This needs to not protrude through the depth of this ring and hit the bottom, otherwise it's not applying any force and it's not centering. We would have been fine with this cone on this ring, but just to keep in mind, don't let that happen to you. So I'm going to glue this one on. I'm going to screw this onto the tailstock. It just happens to have the thread pattern of my tailstock center. I'll use this same glue today since I'm going to take this piece home and finish it, and I want to have it I'm going to make it so that I can take it home and finish it. I would use a brush for this normally, but I put my brush in a cup of water over there, so it's no good anymore. Water is the enemy of glue. Now we're just going to bring this tailstock up here. You want to make sure that you bricklay these rings with a pencil, please. And I will go to the trouble of measuring the first one. So that's about 3/4 inch right there. I go to the trouble of measuring the first one. I don't know if you can see behind here or not, but there's the glue line and there's my mark. So I know that it's bricklayed perfectly in line with this glue joint in that middle of that segment right there. The subsequent segments you can eyeball them because it's easy to see, but for this second ring number 2, I always measure and draw a line so that I can be precise. So then you just do the same process, come back, flatten this ring, get it 5/8 of an inch deep, glue on the next one. So after we glue on all 4 segmented rings, then we're ready to turn the vessel. So I'm going to take this off of here. I think it's good enough. So this is what it looks like with all 4 rings glued on. And this is just basic bolt turning 101 now. I like to turn the outside first and get the outside shape that I want. looking up here while I'm doing this. I'm not looking down here. I'm cutting by feel, but I'm looking up here at the shape that I'm getting. So I took a moment to go get my face mask because I could tell the dust is starting to cause me to cough a little bit, and I am careful about that, so I hope you can hear me okay. But I love this dust mask. I think it's a 3M product, I'm not sure, but these little filters are interchangeable, and this thing works really good. It makes all the difference in the world to me. I've also got in my shop, I've got a pair of these jet air filtration systems. One blows that way on one side of the shop, the other one blows that way on the other side of the shop, so they circulate the air. It's the way to go. So I can see I've still got some flats up here, and I've not done shaping yet. We got plenty of material in here, so don't worry about it. When we made the segments a little bit oversized, we ensured that we had plenty of material in here. So I'm going to go back to turning this round and getting the shape, the outside shape that I want for a moment. All the really good bowl turners have taught me to tuck the tool into your hip and sway back and forth, so that's what I try to emulate. Oh, I still see a few little flats right up here. You can see I've got a little flats here still. I remember I did not trim this top ring down to 5/8, so I've still got that to do, or I could leave it a little longer, optional. And we would, after we finish getting the shape we want here, and I'm pretty happy with this shape, we can sand it on the lathe and then turn the inside out. Still a little flat there. Otherwise, we have a round bowl. Okay, so the outside is done. I would sand it some at this point. And I'll spend a couple of minutes on the inside and we'll wrap this up since we don't have a whole lot of time here this afternoon. And I think our discard memory might be having problems too. So I would just do the traditional rest in here a little bit. I've done that. I think I was a little too acute on that edge right there. This is about a quarter, 5/16 inch thick, and I would probably take it down a little bit more and go all the way to the bottom and get the sides equal in length. But you can see, I know all of you can turn bowls, so I'm not going to try to teach bowl turning here. But you can see the possibilities. I think I'm going to wrap this up and just show you a couple more things that before I go that are within the realm of possibility. This is the same vessel in an open segment style, it's a little more time consuming and it takes a little more planning and thought. But this is something that's certainly within the range of possibilities for segmented turning. This is done by turning a bottom and a top separately with 2 glue blocks, and then you mount it on the lathe and line it all up and glue it together. The advantage of these is you can turn the inside of this and sand it and finish it before, and then you do the same with this one, so you don't have to hollow it out from inside, from a hole in the top, and from which it's hard to put a finish on, sand and finish it. So this is kind of an advantage to segmented work, is that you can build it in 2 pieces and glue it together. There's a whole range of possibilities with segmented work. You can build very, very large vessels. This is large. There are some that I've seen that are very, very, very large, 4 feet tall and such. I don't think I'm ever going to attempt something like that. This is partly open segmented in this area. These are solid rings here, and these are little ebony squares that I glued in at a diagonal in this ring here. When you do a large vessel like this bottom ring needs to be a segmented ring, because if you put a solid piece of wood on here, then when that wood contracts and expands, it's going to break your vessel. So you want to build a segmented ring on the bottom and then put an insert inside the solid ring, and let that be a floating insert. Don't try to glue that to the ring. So that's the success path for building vessels like this. So if you'd like to try something like this, give me a call. I will be glad to help you. Thank you all very much.